Good afternoon, everyone. I hope I'm audible to every one of you. Okay, so let's start with our lecture. Okay, so in the previous class, we were discussing about delegates, right? So we know that the delegate is a type-safe function pointer, right? And it will point to a function based on the signature of the delegates in the target function, right? So let's see. We were in the last class we were discussing the use of delegates, right? So this example we have already covered, but let's just revise it and then we will move forward. So here we have this class employee, right, in which all the business logic and properties of employee class is specified, right? Like properties like ID, name, salary, experience, as well as there is a method promote employee in the type employee, right, which will decide whether the employee should be promoted or not. And this business logic for promotion is also available in the method itself, right? And that's why there is a tight coupling exists here in this method in terms of business rules. Okay, and that's why the class is not much reusable. You can use it for one organization but may not use for another organization. Or say when the business logic even for one organization changes, you need to recompile the entire class. Okay, so that's a problem. Okay, there is too much coupling in the your logic itself. So what is the solution? The solution is delegate. What can we do is that we can create a delegate which is promotable, which will take an instance of employee class and it will return a bool. Okay, so this delegate is promotable can point to any method which is taking an employee instance and returning bool. So now what we will do, we will change the behavior of our promote employee method in the class employee. Earlier we were only passing the list of employee. Okay, now we will pass list of employee as well as the instance of our delegate. Okay, and then for each employee, as we are iterating through the employee list, right, we will just execute our instance of delegate. So when you will execute your instance of delegate, right, then whichever functions is pointed by your delegate would be executed. Okay, so here whenever we say that is eligible EMP, some function, right, which is pointed by delegate would be executed. So now let's see that here, now you can see that in the main method, what we do is we create an instance of our delegate is promotable and it is pointing to a function promote. Okay, so this promote function has a business logic for deciding whether the employee should be promoted or not. It is taking employee instance as an argument and returning true or false. Right. So here in this case, when this is eligible employee is invoked, essentially it will invoke this promote method in the your driver program. Right. So this is how we can say that the business logic is separated from the class itself. And that's why it is more reusable. Okay. So this is how delegate help us to structure our code in a proper manner. Then even we can use lambda expressions, right? So here, so you know that in the promote employee method, it is expecting an employee list and some delegate, right, which will take an instance of employee object and return bool. That we know, right? Because is promotable here is taking an instance of employee instance of employee and returning bool. So we can simply write an lambda expression. Okay, there is no need of creating a method, named method or anonymous method. Okay, you can simply specify your criteria using lambda expression. So as an argument of promote employee, the first is the employee list and second is the lambda expression, which will iterate through each employee one by one. We will check the business logic, right? And based on that, it will return true or false. Okay. Now, let's say we want to implement a facility in which we want to search for employee. We want to search an employee by some logic. Okay. So then sometimes we may want to search by name, sometimes we may want to search by salary, sometimes we may want to search by experience or title. Then we shouldn't be creating different method for different tasks, like one method for search employee by name, search employee by salary, right? That's not a good design. Okay. So what can we do is, here also we can use delegates, because whenever you want to search an employee with some criteria, right, then your argument is the employee instance and the return type is true or false, bool, right? So here this find emp method, okay, it will take employee list and the instance of your delegate find by something. Okay, and then you will just check based on the instance of your delegate something emp, right, whether it is returning true or false. If it is returning true, that means employee has been found, right? So now let's see that which method is pointed by this something instance of find by something delegate. So I can simply use find emp elist in the lambda expression, because the lambda expression will take an instance of emp and return true or false. Suppose I want to search by title, then employee such that employee's title is doctor, or employee such that employee's salary is greater than 6,000. Okay, so that is how using delegate you can achieve multiple functionality in a same body. Okay. So now let me know if you have any question about delegate. Okay, so now let's proceed for multicast delegate. This is the extension of normal delegate concept, and that is very much helpful. So the use of multicast delegate is that it helps point more than one method at a single moment of time. That means through one delegate instance, you can point more than one method. And that means when you execute one instance of delegate, right, not one method, but all the methods which are pointed by that instance will be executed. Okay, so in here, the composition of this method for a one instance of delegate can happen using a plus and minus operator. Okay, and definitely the delegate is of type safe function pointer, so only the delegates of the same type can be composed. So what is the use of this multicast delegate? For example, say when there is a problem, when there is an exception, I want to say write them somewhere, right? I want to log them somewhere. Suppose I want to log them at two places. Okay, say I want to log them in the text file as well as I want to output it to the user. Okay, so now both this function, which is outputting a exception to a user and writing it to a text file, right? Both would have a similar syntax. Both will take some string as an argument or object as an argument, exception object or string message is an argument, and they will not return anything, right? So instead of calling this method two times separately, what I can do is I can create a delegate. Sorry. So yes, what I was saying is that instead of creating two methods separately and invoking them separately, we can create an instance of delegate and we'll point this instance to these two different methods. And whenever we'll invoke this one delegate instance, then those two methods would be invoked, right? So that is how we can create an invocation list of method. We can create list of method which will be invoked together at some point of time when you invoke the delegate. Okay, so let's take an example of it. So here we have this delegate, okay, which is del math op, which has two parameters, both are of type integer, and it is returning void. So this delegate can point to any method which takes two integer as an argument and returns void. So here we have this method add, subtract, and multiply. All three of these methods takes two integer as an argument and returns void. Okay, so now, so we create this del math op delegate, say d1. Okay, and then we create another instance d2. Now d1 is pointing to a method subtraction, and d2 is pointing to a method add, right? So whenever you will execute d1, the subtraction will happen, right? d1 10,5, it would do the subtraction, while d2 10,5, it would do the addition. Okay, but suppose I want to execute them together. Then let's say I have another delegate d3, right? And there I'm composing two delegates d1 and d2, d1 plus d2. So with execution of d3 34,4, it will do two tasks, right? First, it will do the subtraction because d1 is first, and then it will do the addition because d2 is next, right? So when you execute d3 34,4, what it will do? It will execute two methods together at some point in time, at one point in time. Okay, now similarly, say I'm doing another composition using the minus operator, d3 minus d1. So in d3 we had d1 plus d2, and from that you take d1, right, out, so only d2, so only the addition will happen for d4, right? So that's how, and this is multicast delegate. These d3 and d4 are multicast delegate. This is how you can create invocation list of method, okay, using multicast delegate. If you have a question, just type in the chat box. Now, yes, there is a question. Yes, it returns void. So because it will print something on the console, and that's why it doesn't matter, right? It will print on the console. Okay. Answer would be 30. Yes, for D3, the answer would be 30 and 38. For D3, answer would be 30 and 38. For D4, the answer would be 12. Yes, we can make another delegate. Yes, we can do that. We are not adding void. You can see here this D1 and D2 are pointing to a method, right? And these methods are returning void. So we don't have any problem. It will just write on the console. The problem will arise when both methods are returning something, right? Then which value it will return? First value return, second value it will return, both it will return, none of them it will return. Okay. So these are the questions I'll ask later on. Okay, and I'll also give the solution. Okay, D3 is equal to D1 minus D2. Okay, D3 is equal to D1 minus D2. Then D1 is pointing to only one method, right? D2 is pointing to only one method. Then what will happen? The multicast won't happen at all. Okay, because for subtraction, say for example here if you do D1 minus D2, then D1 has only one method, D2 has only one method. There is nothing common in between. Right? This is exclusive or minus. Okay, and that's why the multicast won't happen. Right? Is it a good approach, bad approach? It depends on what kind of, say, goal you want to achieve. Can we do D1 is equal to D2? Why? Okay, yes, we can assign. No problem with that. Okay. For example, here we have this delegate. Okay, print string delegate, and it is taking string as an argument and returning void. Okay, so now say here there are two methods, print string and write string. Print string will write on the console and write string will write in a text file. Okay, so now say you create a delegate D1 which points to print string, you create a delegate D2 instance which points to write string, and then you create another delegate D3 which will compose D1 and D2. So D3 is our multicast delegate. So when you execute D3, both D1 and D2 will execute. Okay, so that is how we are creating invocation list of method. Now this is interesting. So here this del method of delegate takes two integer parameter and it also returns integer. That means this delegate is pointing to a method, right? That will take integer parameter in and return an integer like add, subtraction, multiplication, right? It is returning the answer for addition, subtraction and multiplication respectively. And now here you can see that D1 is pointing to sub, D2 is pointing to add. Okay, and then with D3 we are doing a composition of D1 and D2. Okay, so when you will execute D3, okay, it will execute both the subtraction followed by addition. Okay, but now in the variable R, what would be the value? Which value will be available in variable R? Because when D3 will execute, it will return two values, right? First it will execute subtraction, so it will return an answer of subtraction. Then it will execute addition and return the answer of addition. So which value will be stored in R? 38, the last one, correct, right? Only the last value will be stored in the variable R. That means we are, say, missing some values, right? And that's not a good behavior. So when you do multicast delegate, and as a part of your multicast delegate, if your methods are returning something, then we need to tweak our logic. Okay, it can still return multiple values, but let's see how. Sorry. So here the same thing, the D3 has a reference to D1 and D2. So that's how it is doing the multicasting. Okay, so now say we will use this for each loop, and then we will invoke each instance of D3. How? So the D3 is of type del meth op. So del meth op, it's a temporary variable I in D3's invocation list. So right now in the D3's invocation list, there are two methods which are pointed by D1 and D2, which are subtraction and addition. So we will iterate through each method in the invocation list, and we will execute them one by one. So here, when first time it will execute the method pointed by D1. So first time this return value will have a value 30. In the next iteration, it will have value 38. Right? So that is how, even if with delegate, when you are, say, composing multiple methods, and say if those methods are returning something, right, you can preserve individual return value using this kind of iterator. Okay, so for each loop or any other kind of iterator you need to use, and you need to execute the method one by one based on the multicast delegates invocation list. Okay. Fine, so that is all about delegates. Let me know if you have any question. Then we'll move to generics. And this is our last lecture on C#. Only a couple of concepts are remaining, but we will take them once database is covered entirely in .NET Framework. Right? So after this lecture, we will start with .NET Core. Fine. So This delegate concept, as we will start with .NET Core, you will see that this delegate and predicate. So like delegate, there is a concept predicate. Okay, so predicate will take some argument and it will return true or false. And these concepts are very much useful in .NET Core, right? Basically in .NET Core, many methods are available, and in this method, one of the parameter is predicate. Predicate is like delegate, right? So you can create a Lambda expression, right? You can create a link queue expression and you can pass it, right? There is no need of creating, for example, just a minute. Yes. Later on also we will see, it's in this slide itself, that even there is no need of creating delegate, because in system itself there are some delegates are available, right? So there is no need of creating delegates, there is no need of even creating methods. Okay, but this is a base concept, right, which is helpful for understanding the system defined delegates like FUNC, action, or predicate, which we will be using a lot in .NET Core, as well as if you study MVC in .NET Framework, right? But before we take them, let's talk about generics. Now, the idea behind generics is to allow us to design classes and method which are not depending on data types. They are decoupled from the data types. Okay. So when you want to create a loosely coupled system, right, where you want to have less dependency possible as you can, right, then you go with generics. And these generic classes are extensively used in the collection classes, right? Because when you have a generic collection classes, okay, then types are not specified, right? And that's why you can use these generics. So what you do is you create a template, you create a specification for your class or your method, and then later on you substitute parameters when you create an instance of a class or when you call a method, right? So initially you specify a template. When you want to execute the template, when you want to use the template, you specify the parameter as a substitution of your template. Okay. So here is an example of a method which is R equal. So the problem with this method is that it will work only if the both parameter are type integer. So it can compare to integer, right? It cannot compare to say bool value. It cannot compare to double value, right? So the use of this method is very restrictive. This R equal method, okay, it is only useful when two integer parameter you want to compare. So what is the solution? If you want to make the use of this method for a larger scope, right, then what could be the alternative apart from generics? Is there any alternative? Suppose we want that this method should compare to integer, to string, to real values, anything. Then what kind of changes we should make? Okay, but when you will do overloading, right, you will create many methods. Yes, object is the right answer. Yes, that's good. So what we will do is we'll create a R equal method where it will take two arguments of type object. Because you know that essentially in C#, each type is of type object at the end, right? So we will take object as an argument. But here it will solve one problem, that you can compare to integer, you can compare to string, right? You can compare to object. But now we will have some other problems as well. What kind of problems we will have? Now this method will work. For this kind of scenario as well, which I have typed in the chat box. Right? Yes, correct. So incomparable objects can also be compared. And that is not good in C#. It is allowed in other languages like say JavaScript, say PHP, right? In scripting languages, this is a very, say, fine concept. But here in C#, it is not allowed. The reason is that C# is strongly typed language, right? It's a typed language. And it enforces that this shouldn't be allowed. And apart from this, there is another problem. And that problem is boxing, unboxing. Right? When you will specify integer, it will try to convert integer into object. So boxing will happen. When you want to return, it will return an object and say you want to have an integer. Then you need to unbox it. So there is a performance penalty, right? Because object is a reference type, while all the, say, integer or say double, these kind of types are value type, right? And that's why there is a boxing, unboxing that will keep on happening. Sorry. So these are the two main problems, right? And that's why the generics is a good solution. When you want to decouple your method or a class from your type, right, data type, then you should go with generics rather than using object for your parameter type. So now let's create a generic method. So here we have this R equal, which is a generic method. We specify T as a template. You can use anything, right? You can use your own name. So no problem with that. So R equal, and here in the angle parenthesis, we specify the template, right? And then here in the parameter, we specify that whatever value you specify later on while invoking a method for template, that value will be replaced, or that type will be replaced in the method signature for arguments. Okay, so let's see how we are executing it. So here it is available in the calculator class, and it's a static method. So calculator.r equal, in the template we are specifying int, so the arguments would be of type integer. In the template you specify string, so the arguments are of type string, right? That is how, using generics, right, you are decoupling the method from one specific data type, right? And its usage is more compared to the usual approach of specifying data type or coupling data type in the method signature itself. But these concepts are or should be useful or should be used only if this kind of requirement is there, right? But for any random method, you should not use generics. When you know that it is going to have a fixed syntax, fixed signature, which is not going to change, then you should not be using generics, right? The reason is simple, then you will have performance penalties, right? And normally you wouldn't care for it, right? When you are creating some project or your application is a very low end usage, right? But as your number of users are more than some 1,000, 10,000s, right? Then the performance penalties will be visible in terms of outcome or say running time of your application. Similarly, we can create a generic class. Okay, so here the class calculator itself is generic. So template is specified along with the class name calculator itself, right? And which can be used, the template variable can be used in the method signature as well. So here when we specify the class, then itself we specify what we want to replace, which data type we want to replace with the template, like int string. And then accordingly, the method will have its parameter. Okay, so the class can be generic or method can be generic. Now, generic delegates. That means delegates can also be generic, right? Because ultimately the delegate is nothing but a type say function pointer. So it is going to point to a function, right? So it makes sense that the delegates are also generic. Okay. But here, the interesting idea is these two delegate, FUNC and action. Because of these two delegate, right, we will not require to create delegates in most of the situation. Okay, there won't be a need of creating our own delegate, because in system we have two delegates, FUNC and action. So this FUNC delegate, it is available in the system namespace itself, right? And that's why you know that when you create a default program, using system is always written. So in MS core lib.dll file, this delegate is available, right? So it is that much popular and useful that it is included in the core namespace itself. Now, what is the behavior of this FUNC delegate? So this FUNC delegate, right, it will take 0 or more input parameters and 1 out parameter. That means when you use FUNC delegate, and if it is pointing to some method, right, then it can take 0 or more arguments, but it will return something. Okay, you can see that FUNC will take 0 or more input parameters and it will return 1 out parameter. That means it will return 1 value. Okay, so when you create FUNC delegate, you will specify various parameters. For example, you are specifying int, int, int 3 times. Then the first 2 int is your arguments. And the last int is your return type. That means your return type is integer. For example, you specify FUNC delegate and only string is an argument. Then you don't have any, say, arguments, but you are returning string through the function which is pointing to this FUNC delegate. Okay, you should be careful, right? The next, we will take a details example of FUNC, so it will be clear. Then we have action delegate. Okay, but the action delegate doesn't return a value. That means when you are pointing to a method through a delegate which is returning void, then you should use action delegate. And when you want to return something, you should use FUNC delegate. So here we have these two methods. The sum method, which is returning integer and taking 2 integer parameters. Say hello method, which is taking no parameter but returning a string. Okay, so now here, so I have 2 methods, which is one is taking parameters and returning something, another method which is not taking any parameter but returning a string. So I can use FUNC delegate. Okay, so now I'm not creating any delegate, for example, like a string operation or math operation delegate. Okay. What I'm doing is I'm using this FUNC delegate. Okay, so here I'll specify, say FUNC F1, I want to point it to sum. The sum has 2 arguments and 1 return value. All are of type integer. That's why the FUNC will have 3 parameters, int, int, int. First 2 are its argument and the last one is return type. Right? So whenever now you will execute F1, essentially it will execute sum. But when you will execute F1, you need to pass only 2 parameters. Right? Because that is the argument of sum method. The third parameter is the return type. Okay, so it will just simply return it. Similarly, say we want to execute say hello method by after pointing it to some delegate. So it is returning a string and it is not taking any arguments. So we'll simply specify FUNC string. So the last parameter is always a return value. So string is a return value, which is written by the method say hello. So when you will execute F2, it will return hello. All right. So that is how now we know that there is no need of creating delegates. We can use a systems delegate FUNC or action. We will use FUNC when we want to return something. Okay. We will use action otherwise. When you are not returning anything, you will use action. So here we have these 2 methods, sum and say hello. Sum is taking 2 arguments, returning void. Say hello is taking no argument, returning void. So now we will use action, right? And in the template, you will specify the types of arguments which are passed. If something happens one time, it is considered a mistake, right? If it happens multiple times, right, then you will find yourself in trouble. Okay, so make sure that you keep the disturbance level at the minimum possible level. Okay. Fine. So here we are using this action delegate. Okay. And we are passing only those parameters which are required for the methods arguments, because it will ultimately action is useful when method is returning void. Then comes anonymous method. So anonymous methods are methods with only body. It has no name, right? So we have a named method. So far we are aware of named methods. Now the anonymous methods are methods which doesn't have a name. It has only body. And in C# you can create anonymous method using delegate parameter. Okay, you can create anonymous method using a delegate parameter. Fine. And when you create anonymous method, you need not specify the return type in the anonymous method. Okay, because based on the return statement, it is inferred that this is what you will return eventually. So let's take an example. So here we have this delegate printer. Okay, it takes string as a parameter and returns void. Takes string as a parameter and returns void. So now here, first, here we are creating an anonymous method, because you will see that when you instantiate this delegate printer with an instance p, we are not specifying printer p is equal to new delegate and in the argument the method name. Okay, but instead of that, printer p is equal to delegate, then we specify that this string j is the argument in which should be printed on console. So that is your anonymous method. This delegate string j and your body within the curly parentheses, that is your anonymous method, right? So using delegate keyword, we can create anonymous method. The next, say here, the p is equal to new printer, the new instance of delegate, and then in the parentheses we specify a method name. So there it's a named method, do work, which will just take string as an argument and print that string on the console. So using delegate, you can use a named method like in the last scenario, or you can use an anonymous method like in the first scenario. Okay, so using delegate keyword, you can also create anonymous method. So when you have some task, right, which you will do only one time, then you can use anonymous method, because there is no need of creating named method, right? Now this anonymous method can also be created using action delegate or function delegate, right? And then we do not require to create delegate. So here we are using the action delegate because we want to take something as an argument, but we are returning void, right? So the delegate should be of type action. So action string p, and then our anonymous method delegate string j and the body of method, right? So what is the advantage? There is no need of creating any delegate like printer in the earlier case, right? You can use either action or func based on your requirement. Action you use when you are returning void. func you use when you are returning something, right? While here the action is used with a named method do work. Earlier it is used with anonymous method when we use delegate keyword. Then so here we are essentially using predicate, right? I earlier informed you that predicate will take some parameter. Predicate will take parameter as an input and it will return true or false. True or false. Okay. So for example, say we have a list of string names. We have a list of string names. And we want to find something within the list. Right? So find is an inbuilt method. It's not a custom method that we have created. Find is an inbuilt method. Now what this method takes as an argument? It takes predicate as an argument. So what predicate will take? Predicate will take some constraint as an input based on which you want to perform a search, and it will return true or false. And what is this predicate? It is nothing but a delegate, an anonymous method. Okay. So in the find, it is expecting a predicate. So now we will create this anonymous method. Delegate, it is expecting some parameter, right? String name, and then it will return true or false whether the name is equal to the given constraint, say genal. Right? So that is how we specify a predicate, and the predicate is specified as an anonymous method. Right? So now you will see that how these concepts are useful. The concepts of delegate, concept of anonymous method, etc. Okay. So here using delegate keyword, you are creating an anonymous method, and which is acting as a predicate. What is predicate? It will take some constraint as an input. Here the constraint is of type string, and constraint or the string is equal to genal, and based on that it is returning true or false. Right? For example, your next requirement is that you want to search for a name, right? If it has Z available as a character in the string, then also you can use this. That means now there is no need of creating different methods. What you can do is either you can simply use the find method, and where you want to find with different criteria, you specify your criteria using predicate, and specify your criteria using predicate. And the predicate is nothing but your anonymous method that you create using delegate keyword. But when you have predicate and you create anonymous method using delegate keyword, then there are two things which are required. First, the delegate keyword. Second, the type of parameter. These are the two things that you must specify. Right? The same thing can be done using Lambda expression. Names.find x such that x.name equal genal in double quotes. We can write like that, right? Names.find in the parenthesis x such that x.name equal genal in double quotes. That will also work. So, but that is Lambda expression, and we will come to that. But here we are, and that is also a predicate. That is also a predicate. Why? Because it is taking one parameter as an argument, x, and returning true or false, whether the x is equal to genal or not. So that is also predicate. So what is predicate? It's a constraint type which will take some argument and return true or false. Okay, and now your predicate could be an anonymous method created using delegate. When you create using anonymous method and delegate, then you need to specify delegate keyword, as well as you need to specify the type of your parameter, string name. In the Lambda expression, we will only specify x such that x.name. We will not worry about what is the type of x. Is it string? Is it an object? Right? Nothing. So here in this find, when we specify this predicate as an anonymous method, we use delegate keyword and the parameter type. So now whenever the hand is raised, I'll just try to ignore it, assuming that it is a mistake, right? So if there is a problem, right, and if it's a severe, you can simply unmute yourself and notify me. Okay. So now next is Lambda expression. Earlier we have used it. Okay, so this equal to and greater than is called a Lambda operator, and it read as goes to such to. With a Lambda expression, there is no need of using delegate explicitly, like delegate keyword that we were using for creating anonymous method. So with Lambda expression, no need to use delegate keyword and no need to specify the input parameter type. And that's why it is more convenient to use than anonymous method. Okay. So, and when you write LinkU query, because say, as you will study entity framework code, right? We will use LinkU. So with LinkU, the performance is very good in terms of executing your code aligned with your database. So in LinkU, we always use Lambda expression. Okay. So here, this lambda expression E such that or E goes to E dot ID is equal 102. So here you know that, okay, here this E is nothing but an object of some type, right? For example, here we have lambda expression, elements. So it is our collection, list of integer, elements dot find index. And here we are not specifying, right, a delegate keyword or the type of X. We are simply saying that, okay, you want to have X such that, right, it is divisible by 2. X such that X modulo, sorry, it is not divisible by 2, right? So it will return whether a number is divisible by 2 or not, true or false. So that is also a predicate. X such that X modulo 2 is not equal to 0. Okay, and then this find index will basically return the index of those number, while this parenthesis will return true or false. And based on that, find index will return index. Okay, so this similar, here we have used lambda expression, but you can use delegate keyword, right? And you can create an anonymous method as well. Okay, but lambda expression is always convenient. Okay, so what is missing over here? When we use lambda expression, the delegate keyword and the type of X. Okay. So it's the similar thing, right? Yes, here we'll have both example together. So here we have this employee list, which is our collection, and we want to find an employee whose employee ID is 102. Okay, so it should return a name. If we were try to print the name, then it should be JHP. Okay, so now the one option is that you create an anonymous method. Why we need to create an anonymous method? Because the find is expecting predicate. Okay, so find is expecting a predicate, and whenever on a collection you will perform a search, right, it is always expecting a predicate. So either you create anonymous method, so use a delegate keyword and the type of E, which is employee, and then return, if return true or false based on the employee ID is 102. Okay, now we can use lambda expression, but when we use lambda expression, here you can see that in the find we are not using delegate keyword, but we are specifying what is the type of employee, E, right? We are specifying the type of E. Is it compulsory? Should it be compulsory? Yes, here this employee E, we are specifying that, okay, type of E is employee. Is it compulsory or not? No, it is not compulsory. Yes. So it is not compulsory. You can see that below that there is a commented line, and that will also work properly. Okay, it is not compulsory. If you intend to, you can specify, but then you need to specify within the parentheses. Okay, so if you want to avoid any confusion for later on, right, then you can specify. For example, you are working with multiple types like employee, student, right, etc. Then you want to avoid confusion, right, that whether this E is of type employee or student for your convenience, then you can specify the type, but it is not mandatory. Okay. So similarly, here we are using some more lambda expressions. For example, employee list dot count. So count employee list. Sorry, count number of employee from the employee list based on your constraint. And whenever you have constraint, what you use predicate, and you can use or specify predicate either using anonymous method or using lambda expression. Okay, so whenever you want to work with constraint, predicate is to rescue. Now the last one, it is about lambda expressions. Okay, so here if you see this first code, okay, that expression and then your delegate expression, which is FUNC, which is taking int and bool, right? So here the int is the argument and bool is the return type, because FUNC will return one parameter, so the last one is the out parameter, right? So it is the return value. Okay, so it will return if the number is less than 5. Okay, but whenever we will do this console write line lambda, what it will return is our lambda expression, which is number such that number is less than 5. Number goes to number less than 5. So this is lambda expression, and this lambda expression is normally stored as a tree, right? It's an expression. If you remember in data structure, you must have created a tree for a different expression, right? So it is an expression, and if you want to execute this expression, then you can use lambda.compile and you can specify the parameter, which is the argument of your expression. Here it is an integer, so 2. And when you will print this result, it will be either true or false because it is returning bool. Okay, so this is expression lambda. This first example is expression lambda, and this is our delegate FUNC integer square, right? X such that return the square of it. Okay, so here when we try to print this delegate square, then you will see that what it prints, that it's a system delegate FUNC, right? It's take 2 parameters as an argument, both are of type integer. Okay, and when you specify it with an argument, then it's invoke. Okay, so that is the difference. Here when you try to print this square, it is not printing the expression because it is not an expression, it's a delegate, right? While here when you specify within the expression, it becomes an expression, right? And which will act as a tree. Okay, so it is useful when you have a larger expression or you have a, when you have a more complex expression, right? And you want to debug your code. So that is the place where the expression lambda is useful, right? So when you work with system programming, right? When you are working with multiple parameters, right? Tens of parameters, right? In your one expression, right? And you want to debug your code, then expression lambda is useful. Otherwise, in our case, normally while creating web application, it is very rare that we will be using expression lambda. But sometimes in the next semester in web API, right? When we'll create REST API applications, we will be using a lot this expression lambda. Okay, so that is all about the delegates, generics, and anonymous methods and lambda expression. From this discussion, the important concepts are the FUNC, action delegate, anonymous method, and predicate. And for predicate, either you can use anonymous method with the delegate keyword and the type of parameter you are passing, or you can use a lambda expression. There is no need of, you must not use delegate keyword, but the type of parameter you want to include or not, it is your choice, right? So let's stop here, right? We will take a break, and after break we will start with .NET Core. Okay. Meanwhile, if you have any question, you may type in the chat box. Okay. And in that time, I'll take attendance for those students who are present offline. Thank you.